of convex hull, I'm just telling the definition of. I am asking you that do you know the definition of convex polygon? You tell first. Tell me. Do you know what do you mean by convex polygon?
Yes, sir.
So I am asking before convex hull that
So any
suppose
polygon whose internal angles are not uh, are acute. Are acute.
are acute. Yeah. So this is the convex polygon. You see, and this is non-convex polygon. It may be like this. One example. There are so many examples. Now, so here all the internal angles are less than equal to 180 degree. So this is convex polygon. But here you see this is greater than 180 degree. So this is one definition. Another definition can be this, that if you take any 2 points inside the polygon and if you join them by a straight line, then that line segment will not intersect the boundary of the polygon. That is called convex polygon. But in case of non-convex polygon, if you take 2 points, any 2 points, and if it intersects, you see, in this case, if you connect them, then this intersects the boundary. So this is non-convex. Now you may say that if I take here these 2 points I am connecting, then it is not intersecting. Yeah, it is not intersecting, but the definition says that for any pair of points, means it is my, means wherever I can take the position of the 2 points can be at any point. I mean at any positions. Okay. So for if for all pairs of points inside the polygon, if you connect the 2 points by a line segment and the line segment intersects the boundary in at least one pair of, for one pair of points, then we'll call that polygon as the non-convex polygon. So this is the definition. Now this is a difference. Now we will show you the definition of convex hull. What do you mean by convex hull? Now convex hull is defined for a given set of points. So if you say, suppose let P be the set of points, say set of points, say lying on a 2D plane, two-dimensional plane, suppose. So what is P? So in this case, we are getting these are the set of these are, this is the P. Like this. Now you see, what do you mean by convex hull? Convex hull is also a convex polygon. Okay. So convex hull is a convex polygon. Convex hull is a convex polygon, convex hull of a point set. Otherwise, it is not defined. Of a point set. Point set is P is defined is a convex polygon of minimum area that contains all the point sets, all the points in P. So what will be the shape? For example, you see in this case, this is the convex polygon. Okay. So this shape is convex hull. So convex hull is this thing. Okay. So this is the convex hull. And this is the point set P. Now you see, you can, in other words, I can say like that. Suppose you consider these points as a pin. Okay, so again I am drawing. You may think like this. These are the pins stuck on the board, and now you take a tight rubber band. Okay, so that means and you release this tight rubber band. So it will contract along this if you release this, and it will take the shape of this. You see, if these are the pins, these points are the pins. Okay, stuck on the board. So it will take this. So this is called the convex hull. So this is also the convex hull for these points. Okay, these are the. So now how can you compute the convex hull of a given point set? How can we compute? Okay, so it means point sets are given. So P is the set of points, say P1, P2, P3, Pn. N points are there, where say Pi is denoted by two coordinate xi, yi. P1 x1 y1, P2 x2 y2, like this. Now you compute the convex hull. Please remember, you can see the points. You are the human being, so you can draw. But whenever you would like to compute the boundary of the convex hull, then it is difficult for the computer, because computer cannot see. So only the inputs are given, and you have to design an algorithm so that you can compute the convex hull of the given point sets. Okay. Now, mm, before telling this, uh, say one simple problem means, if you just tell me, I am not going in details of everything. Just here you see, suppose this is the line A, B. Line segment, sorry. You know, this is the definition of segment, means two, it has two endpoints. Uh, a line means it has no endpoints. A ray means it has one endpoints, and another is the infinite direction. Now, how can you detect whether a point C lies at the left or right of AB? Please remember, for example, AB means A to B. Okay, and BA is different. BA is direction is opposite B to A. Clear? Now, so these and these are of opposite direction. Okay, opposite direction. Now, with respect to AB, whether C point C means each coordinates is given. AI is say XA, means each coordinate is like this, say X A Y A. Yeah, like this. XBYB. These are given XBYB. Now you have been asked to compute whether C lies at C lies at left or right point. Question is, the point C lies at left or right of AB. How can you determine? How can you determine? You can see that it lies at the left, but it can be C can be here also, na, this side. So if you extend A B to the infinite direction, then you can say C will lie at the left or right by seeing the figure. But how can you say without means seeing? Means what will be the logic? Can you say? Any of you? How can you determine whether a point C lies at the left or right of AB?
So we can
Sir,
take
we will
origin as
fit.
a reference. So we can take origin as a reference.
Okay. Okay. Any others?
Sir, we will be fitting the point C according to sir our JE theory. We will be fitting the point C
Very
AB,
simple.
and then we will be
Uh,
taking the value of Y.
all of you know actually. I am asking that simple case, simple things. Oh, these I am not saying these are not the answers, but if you try to implement that, it will be difficult. Slight.
Sir, we can
Or
calculate.
Sir, if
one
sir,
by
if
one, please.
both the sir, if both the point lies uh, to the left of both the point, then
In
A
this
and B.
example, I am not getting. What will you tell me?
Sir, sir, another point is that we will be calculating the slope of sir line AB, and then will be
Yeah,
AC,
slope
and
is the answer.
comparing the slope with zero.
I know. Slope is an answer, but you will have to then handle some in this. There are special situations. Suppose the AB is parallel to y-axis, then its slope is undefined. So in that case, you have to again
Yes, yes.
write
In that case,
different code. So forget about the
modify
slope.
something, sir.
Anything else that you know? I'm sure all of you know.
Sir, could we compare the coordinates, sir? That's what I was thinking, sir.
Coordinates are required. Always coordinates are required. But what? How can you
Select the
compare?
slope, sir. Select the slope, sir.
Again, slope. No, I am not asking. Okay, I am saying. See, all of you have seen already. Say, suppose I am writing like this: A, B.
Sir, that less than zero or greater than zero thing. If it
No, 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 no. You see, I'm just telling. Suppose this is ABC. Okay. Now, here you see this is A to B. Okay. This is a triangle. Fine. Now, what is the area of the triangle? Sorry, area of triangle ABC. It is half of. Suppose I am considering in this way ABC. Na? So AX, AY, 1. You know this. Now, I am asking that probably you have seen in your class 11, 12, or maybe earlier. I do not know about the ICSC. So that somebody is getting the answer of for the same value of that somebody is getting the plus 5 unit square unit, or somebody is getting minus 5 square unit. Have you seen this?
Yes, sir.
So you see, you and your friends are getting the same magnitude, but the signs are different sometimes. So what happens actually? I'm saying, if you are taking first A, you see, then B, then C. So if I am denoting this as the M, not M. Okay, you are using so say delta. Okay, delta. So if the sign of delta is greater than 0, then you will see that this is actually you have taken in this order ABC. Means ABC, if C lies at the left of AB, then it is counterclockwise. The rotation you see ABC, then it is counterclockwise, and then sign becomes positive. Clear? And if sign is negative, so here C lies at left of AB. And if the sign of this, you don't need to this half. I am not interested about it. I am interested in sign. So if sign is negative, C lies to the right. Just a minute. Yeah. C lies to the right of AB. This is the definition. Difference. So just taking the sign of, if it becomes negative, then it is positive, then it is lies at this side. And if it is like this, say this is AB, okay, and C is here, automatically you will see that in this case, sorry, in this case A, B, C, it will be negative. It is like this. So by checking the sign of this, I can tell whether a point lies at the left or right. Fine. Now it takes constant, so there is no problem of slope, means undefined or etc. Is it clear now? Yes. Yes or no?
Yes, sir. Yes.
Okay. Now next, can you tell me next questions that how can you tell that whether, just a minute, this is a line A B. Now this is suppose C D. A B and C D are intersecting. Clear? Or it may be the case. So in this case, A B and C D intersects. And in this case, suppose this is AB and suppose this is CD. Are not intersecting. Now forget that you are human being. Suppose you are the human machine. Means you write some logic so that I can check by using the coordinates of A, B, and C, D that whether the two lines A, B, and C, D are intersecting or not. That I want to know. So how can you know? The coordinates are given. Always remember A, B, C, D are given means coordinates are given. What is the difference? Just tell with respect to the previous questions. That means left, right.
Sir, if both points are on either left side or right side, they are not intersecting. And if one
Both point
point
means with respect to AB, you please tell in terms of AB.
yes, sir,
Otherwise,
with
both
respect
point
to
it will be
AB.
difficult for me.
Yes, sir.
With respect to AB, if both C and D lie at the left side, then they are intersecting. You are saying. All of
So
you agree?
they are not intersecting if both points are on the left side. Second diagram,
Not
sir.
intersecting in that case, sir.
Okay. Now, anything, any exception? You see, I am just showing you. Suppose this is AB and this is CD. Both points are lying at the different side, but still they are not intersecting. AB and CD are not intersecting. Check it. But with the CD are on the opposite sides of AB. So please define whatever you have said. Okay, it is to be defined. Any of you see the figures and tell me?
Sir, actually, I was saying with respect to line, like the lines, sir, not line segments, sir. So I have to change the logic a bit.
Sir, we can say that for both the lines,
Sir.
that thing should be true.
Yeah. Tell. For
So for AB, like C and D should be on the opposite sides, and for line
okay.
CD, A and B should also be up on the opposite side. Then it will be intersecting.
Yes, correct. This is the correct answer. That means I have to check whether C and D lies at the opposite side of AB, and also for CD means A and B lies at the opposite side. Okay, then only there are intersections. Clear?
Yes, sir.
Yes, sir.
Is it clear? Okay, so I am not writing. Please, those who are listening. So everything is not. If I write, then it will be time consuming. Now,
Sir,
Uh,
could you repeat the condition
so
once
come.
again, sir? Sir, could you repeat the condition? I didn't really
Okay,
get it.
I am saying that here that means they will intersect. Okay, I am writing if C and D lies to the opposite sides of AB and point A and B lies, you can write and also points A and B lies to the opposite sides of AB. Sorry, CD. Then only they are intersecting. Okay. So both these are to be true. Clear? So what are the condition? This C and D lies to the opposite sides of AB and A and B lies to the opposite sides of CD. If both these conditions are success, then AB and CD are intersecting. Clear? Now, suppose you have been given a set of points, say this, like this. Now you have asked your brother or sister that please draw the convex hull. It is very easy that this will be the convex hull, and suppose he or she studies in class say 10 or 11, 12. So what will be your logic, or means what will be, how can, means I am asking an inefficient algorithm actually. That's why I told you your brother or sister. An inefficient algorithm, very easy algorithm. It may be higher time complexity. That how can you generate the convex hull?
Um, make all possible connections and then
Then
uh,
you know only the positions. Please remember, you cannot see. And please remember, I am telling sequentially, means whatever I am saying that will be required.
Sir, could you repeat the question once more, sir? I kind of forgot
I
something.
am asking that you please generate a convex hull of this point set. Okay. Algorithm, I am asking inefficient, not efficient algorithm. Inefficient. Or say suppose I am saying B go up n to the power 4. Very easy algorithm.
Sir, sir,
Tell.
sir, we will be joining any 2 point, and after that we will get a point right of that,
And
and
after that,
going through this we will be, and after that we will get
I
a
am not,
point after which no point will be there.
I
Sir,
tell
like
it
this, if
clearly.
you get,
Make it.
sir, sir, just think we are joining any 2 point randomly from starting from first. Yes,
Then
sir. And starting from that, we will be finding the point either left or either right of that line.
no, no. Anyway,
With
see,
that
I am
too.
saying, suppose I am saying you that you draw a triangle at random. You draw a triangle at random. Okay. Suppose I am selecting these 3 points. Now after these, all the points that lie within the triangle cannot lie on the convexal boundary. You check it. Am I sure that this point, and this point cannot be the lie on the convexal boundary? That the points that lie inside the triangle. Is it okay or not? Is it possible they will lie on the convexal boundary inside the triangle? These points, these 3 points, you check. Yes or no?
No, sir.
So you remove them, you cut. Fine. So in this case, for example, 3 points are removed. Again, you draw another triangle randomly, not this, randomly. Clear? Please. So suppose you are drawing like this. Suppose you are drawing like this. So what happens now? You remove these one, because this point is inside this point, and also remove this. So you draw a triangle using any 3 points of P. P is the capital point set as the vertices of triangle. Okay, and then remove the points that lie inside the triangle, and continue until it is not possible to get a triangle with means points inside it. That means you draw the triangles, okay, and remove the points inside it. Again, you select 3 points, and then draw the triangle and remove the points inside it, and you continue this. And after some time, you will get. Suppose you have removed, say 10 points, and after that, if you try to draw a triangle, fine, you can draw using the points, but there will be no points inside it. No points inside it means whatever be the triangles, then there will be no triangle. Please remember, the vertices of the triangle will be the 3 points. I am not telling that you randomly draw a triangle whose vertices are not from the given point set. No, I am saying that these points, the vertices, will also be the, please remember, the given points. Okay, so you draw and you remove the points lying inside it. Now if you draw and remove, you draw remove, after certain time, you will, what you will see that again you means whatever triangles are can be drawn, then means all possible triangles has been actually drawn. Clear? So whichever point are left, that will be the convex hull boundary points. Are you getting? Is it clear or not?
Yes, sir.
Now,
Yes, sir.
how much time does it take? How much time does it take? This is a very simple algorithm, but how much time? My question is that how much time it takes to compute
So when
the
does this algorithm
convex hull?
terminate?
Hmm?
So
Tell me.
when does this triangle formation stop finally? I didn't get that part.
Means if you, no, I am saying that what happens, suppose you are removing, okay, you are removing. মামা আমি ক্লাস নিচ্ছি গো, পরে কথা বলছি। Okay, so here sorry, what happened? Again, stop working. not annotated. Okay, hello. Hello.
Yes, sir.
This Wacom is not working. I do not know why. You suppose, for example, you draw. You see, I am showing you here. It is not possible. Then just a minute. Here you see the figure. In this case, what happens that if you um, draw the convex hull here in this means when these boundary points are left, when these convex hull boundaries are left only, and all the inside points has been removed, you are drawing the triangle, and removing the points. So what will happen, all the points that will lie inside the convex hull will be automatically removed by removing the points inside the triangle. So only the points which lie only at the boundary of the convex hull will be left, and after at that time, whatever be the triangles drawn by you using those boundary points, there will be no points inside the triangle. You check it.
Sir, can the triangles be constructed using the removed inside points also in the middle
No,
stage?
what I told, that the three vertices of the triangle should come from the given point sets. You cannot draw any triangle. You can draw the triangle whose vertices will be the from the given 3 points, given point sets. Is it clear?
So given points only, sir. Means after drawing first triangle, some points will be removed from the inside, no, sir.
Yes.
From those points, can
So,
we
so, so, so
construct?
what happened? So capital P was the total set of points. Now P minus 3, you have removed suppose 3 points inside the triangle. Fine. Suppose, or 4 points. So P minus 4. So what are the remaining points? That P minus 4 points. Again, you draw a triangle from those P minus 4 points randomly. Not that triangle again, because if you draw the first triangle again, then you will not get any points inside it. Is it clear or not?
Yes, sir. Yes.
So if you continue this, what happened? After some time,
Sure,
all the
but
points that lies inside the convex hull will be removed. Okay. So now, how much time it will take? Tell me. See, you first tell
Sir,
me.
sir,
Okay. Hello.
n by 3, I guess.
No. First, see, you first tell me how much time it takes to detect whether a point lies inside a triangle or not. I have given you a triangle. Now I have given also a point. The point may lie inside the triangle or outside the triangle. How much time it will take? Means how can you compute?
constant time, sir.
Constant time. Why? Because see, if the triangle,
That's some.
if the point lies always, suppose A, B, C, okay, A, B, C. For example, I am showing here actually because I can't draw. Suppose you see the this triangle A, B, C, fine, and suppose there is a point D. Now, if with respect to A, B, B, C, and C, A, the point D lies at the same side always, then it is inside. You check. Suppose you take a point D inside the triangle ABC, what happens? So D lies at the left of AB, D lies at the left of BC, D lies at the left of CA. But if it is outside, then for AB it may be left, for BC it will be right, or maybe AB for left, BC for left, and CA will be at the right. Is it clear? Yes or no? Tell me.
Yes, sir.
So now you know in constant time I can compute whether a point lies in left or right. So in three comparisons are required to detect whether the point lies inside the triangle or outside the triangle. So now once you compute a triangle, how much time it takes to mm, check whether there are any points inside it or not? Tell me. Once you have computed a triangle, fine. Now there are how many points that you have to check whether those lies inside or outside? How many points are left once you draw a triangle?
N minus 3 in worst case.
Right, n minus 3. Fine. And each needs constant time. Now my question is, how many triangles are possible to draw using n points? You are given n points. How many possible different possible triangles are there? You know mathematics.
NC3.
Right, nc3. nc3 means n into n minus 1 into n minus 2 by 6. So nc3 multiplied by linear time n, because there are n minus 3 points except that. So what will be the total time complexity?
N power 4.
B go up n to the power 4. Clear? So there will be B go up n to the power 4. Now actually then I will not describe everything because this is not the computational geometry class. So I have given you simple algorithm. Then there in cube algorithm also exists, in square also exists, in log n exists. So there was a question. Everybody is trying to reduce the time complexity of the convex hull. Then what can be the minimum amount of time? Means lower bound. Just like sorting lower bound is n log n. So in this case also a lower bound exists, beyond which it is not possible to reduce the time complexity. So further reduction of time complexity is not possible. So what is that? That value is also n log n here. So we'll see it later in the next class. Okay. So thank you for giving me the time. Okay. In this. Okay. So I am stopping here. Okay. Can you please give me a reminder to upload? Actually, I am not getting the. I think by the end of this week, you will be able to upload all this document. Okay. Thank you.